Hi guys, welcome to tutorial 4, question 2. Let's do this. As always, the question is going to be right there. We'll pause it and then try it yourself, and then we're going to go through it together. All right, so like the question says, we're going to write out k equaling to 1, 2, and 3 with repeated substitutions. But, I'm just going to explain like a couple of them, and I'm just going to put them right over here because, you just got to substitute it. It's not that difficult. The first time you do it, obviously, it's going to be itself. You know what I mean? If it's already fn equaling to fn minus 1 plus fn minus 2, when k equals to 1, fn also equals the same thing, fn minus 1 plus fn minus 2. The second time comes around, listen, this, because it has two recursive functions in there, fn minus 1 and fn minus 2, for the sake of the argument, I'm only going to do the first one because I want to be honest with you, it's going to be accumulating way more and more terms, and just doing one of them for this example will prove my point. So I'm just going to do one of them. And, if I do the first one, which is fn minus 1, what's going to end up happening is that it's going to be fn minus 2 plus fn minus 3 plus fn minus 2 from the previous term. It gets carried down, which then, you do the summation, it's going to equal to 2 fn minus 2 plus fn minus 3. And that's going to be for our k equals to 2. When it comes to k equals to 3, we're going to replace that fn minus n minus 2, and then we're going to put the new ones, which is going to be 2 times, open bracket, fn minus 3 plus fn minus 4, and then close the bracket, and then fn minus 3 that gets carried over from before, because remember I told you I'm only going to do the first, recursive call rather than both. And then, you do the mathematical stuff, and it's going to become 3 fn minus 3 plus 2 fn minus 4, which, again, I'll have it right over here. When you do k equals minus 4, k equals 4, not minus 4. When you do k equals 4, it's going to be fn equals to 3 fn minus 4 plus 3 fn minus 5 plus 2 fn minus 4, which is going to be 5 fn minus 4 plus 3 fn minus 5. Now, there's k equaling 5. You do the same thing with k equaling 5 with the first term only. It's going to be 5 fn minus 5 plus 5 fn minus 6 plus 3 fn minus 5. And then, you do the math. It's going to be 8 fn minus 5 plus 5 fn minus 6. This part, just doing it, it's going to be exhausting, but it's very simple. So just there's no way around it. You got to keep doing it. But then, just to put everything together, let's actually get the outcome of every single different case. K equaling 1, we got fn minus 1 plus fn minus 2. When k equal to 2, we got 2 fn minus 2 plus fn minus 3, and so on and so forth. Let's put them together. Let's put them in different rows. And, you're going to see a pattern. You know what I mean? You're going to see that, this is the coefficients look like the Fibonacci numbers, which is exactly the function that we're trying to get the closed form for. Like if you look at it, the OG, the very original function, says fn minus 1 plus fn minus 2, right? That's Fibonacci sequence. And this is what it's showing right here, right now. And that's the pattern that we notice. And then the question asks, why is repeated substitution going to be more difficult to use here? Here's the problem. Like you saw with this question, when there was 2 recursive calls, and they're different, they're not similar, they're different. Like one of them was fn minus 1, and then the other one was fn minus 2. It gets, these substitution methods will not help to get the closed form. Some do. Some of them you might get lucky and, it will work out, but not all of them. Majority of them this method will not work. And, that is why repeated substitution is going to be, more difficult here. All right, guys, that'll be all for question 2. I'll see you guys in the next one.